So let's take up the pyramid question first. So I'll repeat the question. So let's say there is a pyramid of glasses, right? Like this. So first row has one glass, second row has two glasses, 3, 4, and 5, and so on. So there are n, you can say, rows of glasses, right? And what we were doing is we were pouring X liter of liquid at the top, right? And we said every glass has 1 liter capacity. So I said, let's take X equal to 5 for now. So what will happen? This glass will become full. How many liters are left after this glass becomes full? This one also will fill completely. How much is left again after this one fills completely out of the 2 liter? So 2 minus 1, which is 1. 1 is left. So half will flow on both sides. So 0.5 liter and 0.5 liter will flow here. Similarly here, this will get full. Half will flow here. Half will flow into this glass. So at the end of 5 liter, these 3 will be full. This will also become full because half plus half is 1. This one will remain half and this one will remain half. So if you pour X liter at the top with n rows of glasses, you have to tell how many glass will be full at the end. So for n equal to 4 and X equal to 5, the answer is there will be 4 glasses that are filled. So first of all, this is again a common pattern in computer science where you have a pyramid. Any of you have seen another question that looks like this pyramid? Any other question that comes to your mind? Yeah, Pascal triangle, right? So we have 1 here. Then, so everything is like, so every number is a sum of these two. So 1 plus 1, 2 will come here. Then here you will write 2 plus 1, 3. Here also you will write 2 plus 1, 3. And borders will be 1 and so on. So a similar pattern also builds in Pascal triangle. And there are many more problems that are built on the same pattern wherever you see a pyramid like this. Okay. So what is the first step that you do? Just try to number each glass. So how will I number each glass? This glass is present in the first row and it is the first glass, right? So I can number it like 1, 1. Does that make sense? How we are numbering it? Let's look at this one. This is in the second row and the first glass. So 2, 1. Second row, second glass, 2, 2. Similarly, this will be 3, 1, 3, 2, 3, 3, 3, 4, 4, 1, 4, 2, 4, 3, 4, 4. So in a way, what we have done is we have converted this into sort of like a matrix, but half of the matrix. So look at this. This is 1, 1. So if I draw a 4 cross 4 matrix, 1, 2, 3, 4. This glass is actually present here. This is 2, 1, 2, 2. This is 3, 1, 3, 2, 3, 3. And 4, 1, 4, 2, 4, 3, 4, 4. So a matrix lower half is what is formed. Can you all see that? So again, I'm saying this is a common pattern. So don't need to be like, no need to get scared of this. This is a pattern in computer science. Like many of the questions are solved by this. That what you do is basically you are pushing this whole structure and making it aligned to the left side. Like if I push all of these glasses and make it aligned on the left side, this is what will happen. Yes or no? The first one will go here, second 2 will shift here, third will shift here, fourth will shift here. So this becomes similar we do with Pascal triangle. We just push it and they all become like this. Okay, that helps us at least visualize what is happening. In this case, we don't have any numbering. So how do we even point out what glass is this, what glass is this, and so on? Okay, so that is why we have come up with this. Now carefully look, if a glass is I comma j, whatever overflows to which two glasses is the liquid going to flow to, right? So let's look at this. From first glass, it is flowing to next rows first and second glass. Yes or no? From first rows first glass, it is flowing to second rows first and second glass. From second rows first glass, it flows to third rows first and second glass. Similarly, from second, it flows to second and third. So can I say from jth glass of any row, it flows to j and j plus 1 glass of the next row. So I can say I plus 1 comma j and I plus 1 comma j plus 1. Yes or no? I'll repeat what I just said. From any row's first glass, the liquid will flow to first and second. From second, it will flow to second and third. From third, it will flow to third and fourth. From fourth, it will flow to fourth and fifth. So from any j, it flows to j and j plus 1 and of the next row. Is this okay? Now we have a very simple recursion, right? What we will do, we'll first see if the glass is already full, whatever liquid comes, we'll just make it overflow on both sides. If the glass is not full, first we'll try to fill it. And if it still overflows, we'll again push the liquid on both the sides. So let's try to write a quick code for this. Okay, how do we represent a matrix? Cool. So in whatever language you are doing, like for example, if it's Python, it will be list of list. In C++, I'll be using vector of vector. In Java, it will be a list of list again. So whichever language you're coding in, or array list of array list, whichever language you're coding in, I hope you will be able to make this zero matrix. Okay, what should be the type? What should be the type of this? So as I was saying, what should be the type of this matrix? Some of you said int, and that is the wrong answer because we are doing half, right? What happens when I do 1 by 2 in integer? 0, right? 1 by 2 is 0 in integer. So I'll need to make a double, that is a float or a doubles matrix. Okay, so now I think we have everything. Let's just try to code this one out. So I will say I have a vector of. Again, I'm saying list of list if you are in Java, or a normal list of list, like you can create it in Python. Your glasses. And it will be of sizes like, so n rows into n columns, I'll make n into n. I'm not writing the complete syntax. Again, it's a huge syntax like n comma vector int n 0 and all that stuff, right? But we don't need that. So I have this, as I said, I'm not writing the complete syntax here of like n vector n 0 and all that stuff. So you can complete it, like you know it, right? So what I'll do is from main, I'll say pour into 1 comma 1 your x liter. Does this make sense? What is this vector? As I said, it's just a way of representing a 2D matrix. You will see that I'll still be using glasses ij. So if you're using array list, use array list. If you're using normal list of Python, use that. But any which ways, my basic idea is glasses of ij should tell me ith rows jth class, right? That is the idea here. So yeah, pour to first glass x liters. Pour into first glass x liters. Okay. Now let's write the pour function. Int I, int j, and your int x. Sorry, double x. Why double? Because again, it can be fractional. Okay. Let's look at termination. When to stop? When do we not need to maybe still keep on going? Okay, let's not depend first on x. Let's see how we will handle hex. What did I say? I said that if the current glass is full, I'll just pour it on both sides. If the current glass is not full, I'll add to it. And if something overflows, then only I'll call on both sides. So by this logic, X might be automatically handled, and that's not something that you need to look at. You need to look at I and J. If your row number becomes greater than n, that means there is no glass there. It's just flowing into nothingness, and you need to stop. So I'll write if I has become greater than n, simply return. Cool. What to do next? What to do next? I said first we'll check if the glass is already full. So if my classes of ij is already 1, okay. Now one good point here, how do we compare floats? I'm just doing this because these are fundamentals, but still some people are not very clear with these things. So if I compare two floats, let's say 2.0 equal to x, and x also has 2.0, is this the right way? First of all, what do you think? Most of you are saying yes, which is the most obvious answer. But the problem is that with doubles or floats, there are precision issues. So as an example, if I have stored x equal to 2.139, it might on the backend be storing 2.138999999. Am I making sense? Because it just stores it like a division, that this divided by something else. So when you say x equal to 2.139, it might be false, even though you have just put x equal to 2.139, because on the back end, it might be storing it like this. First of all, if this is making sense, because computer just understand 1 and 0, right? It does not store it like 2.139. It is converting it into binary and then storing it. Now that conversion and reconversion might create some precision issues. Okay. So basically what you do is you say, whenever you want to compare floats, you say if x minus 2.139 absolute value, like absolute difference between them is very, very small. So is smaller than 0.00001 or a very small value. So if that difference is very less, then you can say they are almost equal. So you check the two floats that you want to compare, you check their absolute difference. And if that difference is significantly small, right? So 10 to the power minus 10, 10 to the power minus 5, 10 to the power minus 7, whatever parameter you want to take, then you say that they are equal actually. Okay. Here we don't need to worry about it because we are just storing 1. So we'll be going to compare greater than equal to 1. So if this glass is already full, that is, its value is already greater than equal to 1. If this glass was already full, where we are pouring more water, x, what to do? Everything half will flow down. Now I said we don't need this because we are actually comparing greater than equal to, which is perfectly okay to do. So if your glass is greater than equal to 1, like basically either it's full or it's overflown previously only, then what to do? So this is the condition, right? Then what to do? Half will flow on one side, half will flow on the other side. What should I write? Write the recursive part here. So if this glass is already full, like, so for example, if you look at this glass, first, let's say it was recursed via this path, then it got recursed via some other path. So if in one of the previous path only this is filled, then I just need to take whatever is now thrown at me and send it across on both sides. So that is what I'm doing here. If the current glass is already full, then just pour half on the, sorry, I plus 1j. N by 2 and pour other half on other side. You should use 2.0 here. In general, if you are dividing a double by integer, I think it remains double, but you are right, it can depend upon compiler to compiler, right? So safe is to write n by 2.0. It can depend upon compiler to compiler. We should not assume that. So we should write n by 2.0 here. So if the glass was already full, we will just take whatever was thrown at us, put it on half and throw it on both the sides. Now, what if it was not full? First, we will fill it. Yes or no? So what we will say? We will say current glass, first you become full. Ij plus equal to x. N by 2, it should be x by 2. Oh. Yes. And we should also actually return here because this case is over. Now, if the glass has become full, that is same thing. Now, if the glass has become full, what should I do? I should pour the overflown part on both the sides. What should my recursion be? So whatever was overflown is, whatever the value is minus 1, that is the one that will overflow. And half of it you will pour on both the sides. So I'll say pour I plus 1 j glasses of ij minus 1 by 2. And similarly pour I plus 1 j plus 1 and the same thing. Why glasses of ij minus 1? That 1 will remain in that glass, right? That will not overflow. So what will overflow? Glasses of ij minus 1. Now whatever overflows, you put half on both the sides. Is this part making sense? Yes or no? So if it was already full, just take whatever you are getting, overflow. Otherwise, first make this glass full. Now whatever is left, that is whatever you want to overflow, just make that happen. So this question took a lot of time.